Hello, everyone. Thank you for joining Bright Horizons for this special family webinar featuring the Museum of Science Boston. We're very excited to have the museum with us today. And we're excited to have you today for what we hope will be an enlightening conversation about engineering and early education. So with that, very excited, very delighted to be turning things over to Bright Horizons Director of Education and Curriculum, Debbie Hoppy.
Thank you so much, LaDonna. I am Debbie Hoppy, Director of Education and Curriculum with Bright Horizons, and I'm really looking forward to spending the next hour talking about engineering in the early years. It's such a wonderfully rich and engaging topic, and we have with us today Mia Keith. She will spend the next hour with us sharing all sorts of wonderful information about how young children interface with engineering and what we can do to support that.
Hello everyone, my name is Mia Keith and I'm the Director of Professional Development with the EIE curriculum here at the Museum of Science in Boston. I have been a classroom teacher for many years before coming to the museum and have been working with educators of children from early childhood all the way to high school. I'm really looking forward to having this discussion with all of you today about how to engage our youngest learners in engineering.
Thank you so much, Mia. And now that you've learned just a little bit about us, we'd like to learn a little bit about you. We have a poll on the screen for you to engage with, and we just ask a simple question to learn a little bit about you and your children. So just click whether you have a child who is between the under 2 and an active explorer, or a child who's between the ages of 3 and 6 and always tinkering, looking for solutions to things, or a child who is 6 and 12 and just trying to figure out how things work. So I'll give you just a moment to chime in on that poll, and then we can have our poll results shared with us. Great, so it really looks like the bulk of our audience has children under the age of 6, all curious children, and so I think that this session you will find really great information to help support what you do at home and to learn a little bit about what young children do with engineering. So let's explore the E in STEM. This is what we're going to talk about today. We're going to learn about engineering in early childhood and what it looks like. It's such a natural part of what young children do. And so we want to bring some examples to light for you. You'll learn more about what is an engineering mindset, and we'll close with giving you some concrete suggestions for exploring engineering at home. So just to bring you into the conversation a little bit, we have a chat question for you. You can just type in the chat pod, what comes to your mind when you think about engineering? And as you're typing, I just want to point out this wonderful image of this child fully decked out in their sweatshirt that is part costume, but working diligently to try and construct something and figure something out.
Engineering is important for preschool students because it really is a process that they're going to have to learn and explore their whole entire lives. It's really a process of solving problems and learning about disappointment and learning how to bounce back when something's not working the way they want it to.
So here you can see one of the very youngest of children exploring engineering. And really, engineering is so much a part of what happens every day in our programs. Children are natural problem solvers, naturally curious, and really what we do is just provide materials and questions to try and promote that curiosity and that problem solving. And you know, really, if you think about what the definition of engineering is, it's using creativity and materials, tools, math and science to design technologies that solve problems. And that aspect of problem solving is so important. And, you know, in some of these slides, we've seen some examples of just some very basic materials that can promote exploration with engineering. You've seen ramps, you've seen different building materials. I don't know if in one of the early pictures there was a pulley, but that's a common material that you'll see. And what you didn't see in these pictures, but what is always happening are teachers asking probing questions to help encourage the engineering design process. And now I'll switch over to our guest, Mia, and let her elaborate more as we explore the engineering design process with you.
Thank you, Debbie. So one of the things that I want to point out looking at this definition, what is engineering, and I love looking at the chat. So many things about this definition mirrors what I see in the chat. Engineering is all about using your creativity, understanding the materials that you have available, and drawing on like any prior knowledge regarding math, regarding science, regarding even things like ergonomics and design like aesthetics to create technologies. Now I want to delve a little bit into this idea of creating technologies because in our very high-tech centered world, when we talk about technology, the first thing that comes to most people's mind is going to be high-tech, cutting-edge, usually digital technologies. We think about iPads, we think about smartphones, we think about computers and all these things. But we don't often think that a technology is simply an object, a system, or a process that helps us solve a problem. So a common spoon is a technology. It's an ancient technology, but it's still a technology. Somebody had to think, wow, if I want to eat soup, I could either slurp it out of this bowl or use my hands. The latter is messy. What could be better? And they designed a spoon. And so the thing about that that's important is that from the EIE standpoint, we really see that everybody is capable of designing technologies that can solve problems because even the youngest learners can use the materials around them and their creativity to solve problems. And those things that they make, those solutions are the technology. And that is a really big deal. And I just wanted to take some time to talk about that. So if we could go to the next slide, I want to talk about another piece of engineering that is really integral to what we do here at EIE, which is using the engineering design process. It sounds like we have a really knowledgeable group here listening today, and so people have probably heard of the engineering design process before. A lot of people, when they think about what engineering is, they will think of something that's really complex, something that's really adult, something that takes a lot of time and a lot of like training and skill. And that is true for people who are out there as paid professionals and engineers. But the truth of the matter is we're all born engineers and we all do this kind of problem solving every day. And we use the same process that these trained engineers use, just sometimes in a more scaled down pattern. So at EIE, we've thought about how can we introduce this process of engineering to young learners. And so we've designed a 3-step process to encourage this engineering mindset for our youngest learners. So for our 3-year-olds in preschool, when we try to encourage them to problem solve, we want them to first explore. And you can see from the poster that's on the PowerPoint that explore, find out more. We want them to get involved with the materials that are available for them to solve the problem. We want them to start asking questions like, oh, well, is this soft? Is this hard? If I shake this, will it make a loud sound? So we want them to really get in there with their hands and really start to just experience what they have in front of them. It also helps to build their background knowledge so that when they're trying to solve problems in the future, they have other things that they can draw on. The second step is for them to create. They start thinking of things, ideas as they're exploring. They start to think about ways that they could solve the problem in front of them. So we give them the opportunity to start creating their technology. Take the materials available along with their ideas and create a solution. Now, we understand that no matter how old the engineer is, the first solutions oftentimes won't work. and they have to have an opportunity to try again and to make that technology better, which is why the third step is to improve, make it better. And this is a big piece of our engineering design process, is that we feel like there needs to always be opportunities for learners of all ages to try again and again to see if they can solve the problem or solve the problem in a better way. As your learners get older, they can start to think about the engineering design process in a more complex way. So in elementary, we introduced a 5-step process to them. So we actually asked them to think a little bit more deeply about some of their questioning. For example, we ask them to usually start with an ask step. They can start asking things like, what are the criteria for success? What are the constraints? What am I allowed to use and what can't I use? How much time do I have? And after they've asked some of these important questions and also done some scientific experiments to learn more about materials available, then they can jump into imagining what these solutions would be. And we provide them with engineering notebooks and papers so they can start to draw and write their answers. And then at the older ages in elementary, we ask them to work in groups. So we bring them together to come up with one plan. And this is really important because it helps them to develop these 21st century skills of collaboration and communication by taking the things they imagine and putting it together with other people's imaginings to create one plan. Then as a team, they'll create their technology, and again, they have the opportunity to improve. And they can complete this cycle multiple times, and they might even bounce around from one stage to another. They might imagine something new and then create again, because the engineering design process is cyclical, and it can be repeated over and over again. So in the next clip here that LaDonna is going to go ahead and push out for us in a moment, you're going to have a chance to see some of these developmental aspects that engineering can bring about come into play.
I think it's important to start engineering quite young with children. If you look around at any child at age 3, children are natural engineers. They're constantly building and rebuilding forts, ski jumps, sand castles, trying to figure out how to create them so that they make them better. If you can start young enough, you can get children engineering and understanding they're capable of doing this before the pervasive stereotypes about STEM and who can do STEM and who is good at STEM start to sink into their consciousness. So 3-year-olds haven't yet been completely socialized that they're not capable of doing things because they're a certain gender or they look a certain way.
I love that video. It features Dr. Christine Cunningham, who's the founder of EIE and one of the first early thinkers in designing engineering curriculum for young learners. And that video is amazing to me because it's a really great example of some of the reasons why we want to encourage engineering education in the early childhood arena. And it helps with a lot of aspects, including a lot of developmental aspects of the child growing. And so, Debbie, did you want to speak a little bit about some of the early development that goes along with engineering?
Yeah, sure can. So if we think about engineering, Mia, it incorporates so many areas of development, and really they're all integrated, right? It's not like engineering just focuses on math at this moment or on language at another moment, or executive function skills that help children process, organize, thoughtfully plan, and carry out acts. It really just embeds everything all together. And this picture really is, an example of how engineering supports social emotional growth and development. Oftentimes in our program, children are trying to solve problems together, and that really requires them to listen to others, to register what others are saying, to contain their own thoughts and respond to others. And these are all very sophisticated social emotional competencies that engineering naturally allows for. And in early childhood years, engineering experiences are full body experiences, from the youngest of children exploring with materials to figure out how much they weigh, how heavy are they, can I move them with my body, what happens if I take something and I push it, what happens if I move in front of an object. Those are all really beginning engineering skills, because without the foundational knowledge of how materials work and function, there's no building without that. Children need that foundation. They need that hands-on experience to know what impact they have on a material. And here you can see these children need to understand how much pulling is the right amount of pulling to pull the bucket. How much might be too fast? And then what will happen? Will the bucket spill? What happens if I move too slowly? Will the bucket get off the ground? And without the very early years of being able to freely explore materials, they don't have that knowledge. And of course, integrating language, it just comes naturally. Having children articulate their thoughts, articulate their questions, articulate their findings. And of course, all wrapped up also into the social emotional competencies, sharing thoughts with each other, and negotiating and listening and responding. And if we think about executive function, and if you think about executive function skills, they're really the skills that help us all stay organized, prioritize, as adults, prioritize our work or things that need to happen. It helps us gives us skills to follow through. It helps us, our executive function skills allow us to keep something in our mind while we're acting on something else. They allow us to listen to others, understand what others are saying, and contain our responses. And it really help with self-control as well. And all of those competencies are boosted by participating in engineering experiences.
So I wanted to talk a little bit as well about the engineering mindset. Everything you said was so beautifully said, Debbie, and thank you for that. And there's something else about development that EIE has identified really early in our studies as we were creating the early childhood curricula, is that we really wanted young learners to have a distinct idea of what it means to solve a problem. It's really interesting when we started asking young kids about what a problem was, many of them would say that, well, it's a problem because Carol won't share her crayons with me. And that is a problem, not necessarily an engineering problem. So one of the things that we had to do was really work to figure out ways for them to start to think about engineering problems in a real-world context. And in doing that, it really helps with a lot of that, developing that mindset in some of those early developmental skills, because they do have to start using their executive functioning in a different way when they start to think about what kind of material would solve a problem, as opposed to, I really want to use this material because it's pink. So we start to get them to actually think about data sets even at a young age, because they're collecting data about the materials they touch. Well, this one is really hard. This one feels heavy. I think a hard, heavy material might be better at making a wrecking ball than the soft material. So it really helps them to start thinking about problems in a real-world context in a way they hadn't before. The other thing that is amazing about engineering is that it creates a resilience, a persistence in the engineer, in the young learner. When people engineer, regardless of age, they're going to come across failure. And they're going to try solutions that don't work, or they're going to think of things that don't fit within the criteria and constraints for success, and they will have to try again. And the thing that I love about developing this engineering mindset is that we encourage all children who are engineering to recognize that when a solution fails, it is the technology that is failing, it is the design that is failing. It is never, ever, ever the learner. The students don't fail, engineers don't fail, learners don't fail, designs fail. And that's a huge takeaway because we want to encourage failure. I think it's oftentimes especially in school, the idea of failing comes with this idea that you're somehow not good enough. But in engineering, we really push the idea that it has nothing to do with you. You are just one step closer to figuring out what does work every time a design fails. So we encourage it. I used to, in my classroom, I actually had a failure dance that I would do with my learners so that when a design failed, if a tower fell down, then I would say, oh, wow, now we know one thing that doesn't work, so we can find something else that does. And then we would do this silly little dance. And the kids really got into it. Whenever a design failed, they would stop and do the failure dance. And it allowed them to just let go of those things and move forward with persistence, and also to recognize that they are growing every time they see something that doesn't work. So it helps with that growth mindset, which to me is interwoven into the engineering mindset. And then, of course, creativity and critical thinking is all wrapped into that. A really good experience in engineering should have so many opportunities for solutions that even the person who is trying to facilitate the engineering activity can't figure out what the solutions all could be. I often say, if I know all the answers, I'm not doing my job well enough. I want all the learners that I come in contact with to think of things that I haven't thought of before. And that's really the magic of engineering. That's where all of our technologies have come from, is from this idea of creativity and thinking outside the box and critical thinking. And engineering allows for that experience for the youngest learners, which is one of the reasons we encourage it even in preschool, where some people are a little surprised to see it happening, but we're like, nope, it's happening and it belongs. Debbie, was there anything else that you wanted to talk about regarding the engineering mindset?
I think, the point that you mentioned just about the time and space to try again. I love the fact that you talk about not the person being the failure, but the technology, the solution. I think that we just have to keep that in our mind, because as we grow older, and I watch as children, age from 2, 3, 4, 5 into their teen years, I watch, the very young children. They're pretty okay when you try something and it doesn't work out the way they had planned. They go back to the drawing board and they try again. But as those same children near their teen years, they become more discouraged when things don't go their way. So there's something that happens with that process of working through that and trying again and having that tenacity. Something changes a little bit. And so the more that we can keep that intact and keep that alive and sort of free space for children to design solutions that don't work and to try again is so important.
Absolutely. I mean, I love that you said that about how as humans, as we grow older, we become more afraid of failure. One of the things that we've seen over and over again is that younger learners will jump into a design challenge far quicker than older learners, because the older learners are already afraid of what if I don't get it right. And we've found adults to actually be the most afraid to engineer, because our egos have just grown so large. And we're so afraid of failing. And so I think that's super important to realize that when children are young, they often are really they're very resilient. They will go back and keep trying and trying again. And as parents and guardians and teachers, it's important for us to keep encouraging that mindset as they get older, and encouraging this idea that you never fail until you stop trying. You just have to continue to try at it and try new things and explore new things. And finding the magic in the exploration, because to me that's where the kernel of it is the exploration. It's, you know, we do all want to find the solution, but it's about that journey, and I think that's an important piece to call out.
Yes. And I think, you know, I noticed in the chat that someone in the audience mentioned that they use the We Engineering curriculum in their program, and that is something that we have used in our programs as well in partnership with Mia and her team. And one of the things that the children have been exploring just now is the Noisemaker Challenge. And there's a couple of things that I love about the curriculum. One, the fact that they're called challenges, because I think that is such a powerful word for young children, and it does not connote that there is one answer, right? It's a challenge. It's a challenge to be conquered, and you can conquer it in so many ways. And I think I think that word challenge is just valuable when thinking about how to explore engineering. And one of the Noisemaker Challenge, Nia, do you want to talk a little bit about the idea behind it and what children are tasked with doing, and then I can give an example of something that led to in one of our programs.
Absolutely. So the Noisemaker Challenge is one of 4 challenges in EIE's We Engineer curriculum, which is designed for preschool. And in that particular challenge, I should say that in We Engineer, all the challenges are introduced to the learners using a puppet. The puppet is a member of their classroom, and the puppet always comes with a problem that the puppet would like the young learners to help engineer a solution for. So in this challenge, the puppet comes to the kids and says, I've been invited to a party, and I really would like to have a loud noisemaker to use at this party. And the puppet produces a noisemaker that he's already made, and he shakes it, but it's a really quiet noisemaker. And he looks really sadly at the kids and goes, I don't think my noisemaker is very good. Can you help me make a better one? And so then the learners are allowed to explore all different kinds of materials, from plastic buttons, like large plastic buttons, they're very safe, to ribbon, to see which ones could make a loud noise. And before they even get to making the noisemaker, they go through exploratory stages where they just get to experiment with sound and those materials. And then once they've experimented with the materials, they get to make the noisemaker. And one of the things that I really love is that every child in the room is allowed to pick one material that they think makes the loudest sound and would make the best noisemaker based on their exploration. And they put that into a box that no one can see inside. And at the end, the teacher dumps out the materials and can help them explore the different materials that were chosen and why. So it's a really great way for the learners to point out why they chose certain materials, or why they think there might be, let's say, a lot of buttons but not very many ribbons. So it gets them to do that critical thinking. They could be like, oh, maybe it's because the buttons were big, or maybe it's because the buttons were hard. So I love that activity. It's a lot of fun. I'd love to hear how this has played out in your centers, Debbie.
Great. So what Nia is talking about is the We Engineer curriculum that Museum of Science has created and that we have used in some of our programs. So that is just giving an overview of one of the experiences. But so from this Noisemaker challenge, from this problem that the children had to solve, they explored a variety of materials, and after about 4 weeks of exploring, one of the children posed the challenge: can we make a small noisemaker that is louder than a really large noisemaker? And so they went around the school and they collected boxes of different sizes. And they found a really large box and a really tiny box. And they started to explore explore with small materials and putting them inside each of those different boxes to see what sounds could make. And this went on for quite a while because, as you might imagine, putting small materials in a large box gives opportunity for that material to move around and make a lot of noise. And as young children like to do, they like to try and, stuff a lot of materials in a box sometimes. So they were putting a lot of materials in the small box. And when you put a lot of materials in a small space, there's not really enough ability to shake and make the noise rumble about. So after trying this for quite a while, one of the children came in with a whole bunch of cotton and tissue paper and put all of that in the large box, and then put a few metal bits in the small box. And together they explored again, and lo and behold, they had created a noisemaker that was smaller yet louder than the larger one. So that process just wouldn't have taken place without them working through the engineering design process. And just from that, they were able to take it and run with it. So some of our programs in the Boston area are using this curriculum in their kindergarten prep classrooms, and it just really not only enjoy the challenges that are posed to them, but the ones that they then find within their own classroom based on what they've been learning. So it's been really wonderful to watch.
Love it.
Yeah.
I wanted to take a moment to reflect on a question that Donna and Sylvia had around when young learners become frustrated and they no longer want to engage. Because I think that happens to all of us at every age, where we just sometimes are just done. But one of the things that we found that is really important to persistence and engagement is having a real-world connection to the challenge or the problem at hand. If a learner doesn't feel engaged, it's probably because the question at hand isn't interesting to them. So sometimes it's putting the question into a context that means something. Build a story around it. So that's one of the reasons why we use a puppet to introduce our design challenges, because the kids will become much more engaged because they want to solve the problem for the puppet sometimes. They're like, yeah, I really want to solve it for him because he needs this now. We got to do this for him. So that helps with engagement, helps them persist when things aren't working. I know working alongside or with others can be really encouraging. A lot of times people feel like, I want to do this because this is fun and I'm doing it with this person. That can be great. Stories that are interwoven with challenges can be really encouraging. If they have a favorite story but character and they have a design challenge that incorporates that storybook idea, that can be really engaging for them. So there's lots of things that can keep learners involved with the engineering challenge. But the other thing I think to recognize is that sometimes people just need to walk away. And if a learner's feeling frustrated, they may need to just take that time to walk away and may find themselves re-engaged with the activity at a later time.
Yeah, and I think it's so important also for us as adults to model our opportunities to try something again. When something we try doesn't go as planned, or when something we're working on is frustrating to us, as adults, as teachers, this is really a strategy we use, and it's also a really great strategy for parents, is to sort of speak aloud and say, oh, I am trying, I'm trying to unscrew this screw from the cabinet that I'm trying to fix. But I'm getting frustrated because my screwdriver isn't catching. Maybe I need to try a smaller screwdriver, or maybe I need to try a larger one. And modeling that self-reflective talking to your child helps them see that they're not the only ones who go through that sort of frustration moment, and it also gives them cues on how to work through it. That reflective talk is so important. And it is such a model that children pick up on. And learning alongside our children. As teachers, we do this. We often say, I don't really know how to solve this problem. What do you think we could do together to try and figure it out? And just being sort of in that physical presence of your child really gives them a little bit of confidence to forge ahead in a way that they might not feel comfortable doing sort of in their own space. There's lots of great questions coming in through the chat, and momentarily I'm going to share a few ideas to do at home, but I just wanted to respond to one more question, and then LaDonna, you can move to the next slide. I'm going to ask the question about what to do with 0 children, very young children to 2-year-old children. And I'm just going to share a story about something I observed in one of our early childhood programs. And it was children under the age of 2, but they were walking, and they were outside. And outside of this program, there was a hill. It might not seem like a very big hill to us as adults, but it was a big hill when you are 18, 19, 20 months old. And there were wheelbarrows and then there were some pylons, some of those orange cones. And what I watched happening was engineering process unfold with children trying to get the wheelbarrows up the hill. And first they tried to get it up the hill by themselves with the wheelbarrow empty. And sometimes the wheelbarrow would flip, and sometimes they'd fall backwards. And then sometimes another child would come along with them, and each of them would have their hands on one of the handles on each side. And they would try that until they got it up the hill. And after a few times of trial and error, by the time they got it up the hill. And then they would let the wheelbarrow go and watch it fly down the hill. And then they would run back down the hill, and now they were taking the pylons and starting to put those in the wheelbarrow and trying to get them up the hill without the wheelbarrow falling over. And all of this is engineering for the very young. They're trying to solve a problem. They're using their bodies. They're beginning to work together to collaborate at the very beginning stages of that. And they're going through trial and error. And when something doesn't go their way, and they would like to see a different result, they go at it again. And that's really what it looks like in the very early years. So I thank you for that question. LaDonna, we can move forward to the next slide. Nia, before I enter into the slide, is there anything you wanted to add about the very early years?
No, I think you summed that up really well. And I guess the only thing I would add is that because engineering does incorporate so many disciplines, that your story was really great in showing not only the engineering design process in motion, but them learning the basics of physics and then figuring out the basics of math, and all of that was happening at the same time because they were trying to problem solve. And that's one of the things I love about engineering. It just brings all those disciplines together, and it helps them to apply those things in real life.
Yeah, it's so wonderful. And so much can happen at home. I have a son who is 12 years old, and his engineering still focuses on interacting with materials and trying to solve a problem. In our neighborhood, on trash day, we have to bring the trash cans to the end of the driveway. And part of my children's part of how they contribute to the work in our houses, they bring the trash cans down and they bring the trash cans back. And on one day, my son said, "I'm going to bring the trash cans back." And all of a sudden, I saw him on his scooter with a pile of rope in his arm. And my natural inclination was to say, "You're on a scooter. How are you bringing the trash cans back?" And really, what he was doing was engineering. He was about to solve a problem. I watched him go down He left his scooter at the foot of the driveway. He came back. He got his bicycle. He got a little bit more rope. He tied each of the trash cans with the rope to the arms of his bicycle, and he put one trash can on the scooter and tied that in and pulled all three up at the same time. And what he had done was just engineered a tool, a technology, to bring trash cans from the end of the driveway to the beginning. And even though, he was 12, it was just the physical interaction with materials that really got him to his problem-solving abilities. And the trash can on the scooter did not always stay on the scooter as it made its way up the driveway. And he would have to stop, figure out why it was falling off, and plan something new, try something a little different until he made his way back. And those are the kinds of experiences that really are so valuable to provide at home. Open-ended materials that allow for exploration. A lot of these questions, especially for younger children, these open-ended questions really help provoke children's thinking. And I think as we were talking about disappointment and not really wanting to forge through, sometimes I think children end up in that space because, unfortunately, sometimes they just think there's one right answer. And if we're thinking there's one way to do something, then we aren't going to have the tenacity to try again. So by having these open-ended questions and being open to possibilities for solutions, I think that's a way to really help children overcome that disappointment and encourage engineering. So things like, what do you think would happen if we X, Y, and Z? Sometimes that reflective thinking, I can see that trash can keeps falling off the scooter. What do you think we should do about that? Sometimes even also acknowledging their frustration. I can see that you are frustrated. This is not going the way that you are envisioning it. Let's pause. Let's take a breath. And let's try something else. What could we try together? All of that language is so helpful to nudge them along. And it's a fine line. It's a fine line. We know our children's frustration level, and we don't want to make them so frustrated, but we want to support them through that threshold of frustration. We call it the zone of proximal development, sort of where children are and where they can be, where their learning can be, with a little scaffolding, a little support, by asking them some open-ended questions, by being by their side as physical encouragement. That really helps keep them going. Also at home is using science vocabulary. You noted how Mia, brought some of that science language to the wheelbarrow exploration, the concepts of, physics and motion and gravity. And so using scientific vocabulary in your discussion really helps children begin to understand the scientific process. It helps them put names to physical properties, and eventually then they start adding that into their own language. And so science learning doesn't have to be a sit down, we're going to do this activity for this 10 minutes and then it's over. It's a much more open-ended experience. Someone, Katie in the chat posed a question, why didn't that work? What can we change? What might we try differently? And that falls right into embracing trial and error. And that's a hard thing to embrace in our world today, but it really is so important. And one of the ways we embrace trial and error is by giving time and space for children to explore. You can't really have trial and error if there's only 5 minutes to do it. And so seeing how you can provide some open-ended time with materials that allow children to have that space to try again. We do live in this pressure-timed world to get to the next thing, but wherever we can carve out that time to give children that freedom, that also takes away from that frustration. Like, oh, I have to get to the right answer before time's up. If we have just a little bit more time, there's no right answer before time's up. There's a lot of possibilities to explore in that time. So these are all things to encourage at home. Mia, do you have anything to add to that?
Yeah, just a couple of comments. I mean, you hit on so many great things there. And I really like what Katie was saying around asking more questions. In fact, we encourage our teachers to learn that strategy too, and it's something parents can definitely model at home, is just continuing to ask questions when the child is frustrated. If they're engineering and they're trying to find a solution, it can be so tempting to just point out the answers, but it's so much more productive by just continuing to help ask questions that are going to probe into the problem. So most likely you will know what's happening. You'll know what's wrong. And you can ask pointed questions like, what do you think would happen if you used this block instead of that block? Why did you choose this material? And see if they can start to give you some insight into their thinking, because they will. They'll start to develop that more and more, and you can get insights to their thinking. You can help nudge them in the direction just by helping them to question their process in a way that maybe they haven't questioned before. Another thing that I wanted to talk about is this idea of becoming comfortable with failure. I find oftentimes it is the adults involved in the engineering design process that are the least comfortable with the failure, not just seeing failure in things that we are doing, but we have a hard time sometimes watching our kids go through a struggle. It can be difficult, and we want to rescue them. We want them to feel good about the situation. And if you see your child really, really having a difficulty, that's one thing. But if they're simply just frustrated and kind of grinding through it, it's okay for us to also step back and take a deep breath and just be like, okay, I know they're going to figure this out, so I'm going to sit back, I'm going to ask some questions, I'm going to smile, I'm going to encourage them, and I'm not going to get in the way of their process. And that is, I think, one of the hardest things sometimes as a parent or a teacher to do, but one of the most rich experiences that we can give the kids is that ability to just, like, solve the problem on their own.
So true, Mia. As both a teacher and a parent, I feel that temptation. And one of the things that I've done actually as a strategy to remind myself not to sort of jump in and rescue is I sit on my hands when I'm feeling that moment. And it just gives me that physical prompt to remind myself that my child is capable of figuring this out in their time and their space. And it really is it's a silly strategy, but it works for me.
Yeah.
So thank you so much for that great idea. We are nearing our time, and I think that we've hit a lot of your questions throughout this process. This past hour almost with you. There might be a few that we haven't hit, but we tried to take the salient themes that we've seen come across and respond to them. And so at this point, I think we're going to turn to LaDonna and close us out for the afternoon.
Yeah, thank you so much, Debbie. And I'd like to just kind of echo Debbie's comments. A lot of really great questions and conversations going on in the chat. For any questions we weren't able to answer, hopefully we'll be able to address some of them on our Family Room blog. So you can certainly look up for that. And your questions also can help us inform future content, particularly for our Teach, Play, Love podcast. So really appreciate your participation. I'd also like to just give everyone a quick preview of our next family webinar. It is taking place on July 24th, same time, 12:30 Eastern. And for this session, we are going to be particularly talking to the new and expectant parents out there about the first year of parenting. at home with your little one, but also back to work as you transition into being a parent at work. So we're really excited to be joined by the mother-daughter duo, Marty and Erin Erickson from the podcast Mom Enough. So we hope that you can join us as well. Look out for your invitation to register for that event next month. So with that, I just want to thank you all again for joining the webinar, and I'd like to thank Debbie and Nia. Debbie and Nia, if any final closing words, feel free, but we really appreciate the expertise and the passion that you shared with us today.
Thank you so much for inviting me to come and talk with your parents and your audience today. It was fantastic, and I do hope parents check out the We Engineer website. If they do and they're interested in the challenges, there's actually a free challenge, the Noisemaker Challenge, they can download off of the website if they want to give that a try with their own little ones. So thank you so much.
Thank you. It's been great spending time with all of you. It's wonderful thoughts going on in the chat, and we hope that you are inspired by some of these ideas. So thank you for your time with us today.